Okay, so welcome back to a lecture on aquatic forensic geophysics. This is dominantly from my colleague Alistair Ruffell at Queen's University Belfast, with Viv and myself at Keele University. These plots on the left is showing a hydrographic survey of an area next to a bridge, and this is actually some munitions that had a near miss on the bridge. You can see sort of blue coal colours on that, exactly where it's located. And on the right, there's a pier. A bridge pier here showing some where some scours have been undercutting it using some imaging equipment. So by the end of this presentation, we should talk a little bit about basics of locating aquatic targets and showing you how some of those can be used to aid archaeological and forensic investigations. We're going to cover some typical geoforensic applications like we did in the terrestrial presentation and show you some sort of methods for doing this. Okay, so part of the problem in water, a lot of people are reported missing in and around water, and the World Health Organization reports drowning as the third highest cause of death. As for missing people or suspected murder victim people, roughly 30% are deposited in water, so they reckon only 10% are in earth-cut burials and most are in structures. But where to start in water? It's usually zero visibility in UK waters, and there's a lot of things to worry about. You think it might be a homogeneous medium, but it isn't. There's a lot of variables you need to consider, such as the water salinity. Is it salty to fresh water? That will differ your techniques you're going to use. Currents, where people perhaps went missing and where they might end up being. The water depth. What's the actual substrate on the bottom? Is it muddy, silty, rocky? Is there any sort of vegetation to obscure things? The season that you're doing your surveying, see that there's the seasons that people went missing in. And for example, if you are talking just people, and other items you're looking for might be weapons or caches of forensic items of interest. Are they floating? Are they submerged? How long have they been submerged for? Are they in the mid-water column? Are they on the bottom of say the pond or the river, or are they below the sort of water substrate interface? So some variables to consider when you're detecting your targets. And what other methods could you use? Well, thermal imaging might work. We've talked a bit about that in the previous lecture. For example, if they're floating, you might be able to pick them up as a thermal signature, even after death. There's an example on the left with some meat in a tank. You can see it looks like relatively hot compared to the background areas. So that's one method. Divers obviously are useful, but that's fairly slow if they're trying to grid out a search area. And actually search dogs are surprisingly good at detecting scent cones in water. You can see there's an image here showing you you could actually smell a scent down current of whatever the target might be in that example. So for aquatic targets, we talked about missing people, of course, but other things in there could be weapons people tend to dump to try and avoid detection. That's really important for forensic investigators to find. Might be drug stashes. We'll show you an example of that later. Could be environmental, illegal pollutants, detecting it again, as for terrestrial environments. Could be wildlife. Again, we're going to show you an example of that. So again, as per the terrestrial methods, there needs to be some geophysical contrast between your target and the background materials. And the nature of the environment is as important for terrestrial searches. So certainly a depth study is really critical before you go in the field. And usually that'll be in some sort of georeference system these days. And so for those examples, you can see here, it's one of Alistair's review papers. You can see they're sort of looking at modern and historical maps, see if there's any changes from when perhaps things were deposited to what the timeline is now. Some more information on aerial imagery, perhaps, the soil types, the underlying geology. That's going to help you decide what techniques to use or what potential variables you need to worry about when you're doing your surveys. Here's an example, electromagnetics and metal detectors. So you get marine versions of these, or water versions. They're usually towed behind some sort of device, usually a boat or a dinghy or a kayak or whatever, depends what scale you're looking at. For very large scale, such as the example on the right, looking at it's actually magnetic striping in the oceanic crust. That's how they looked at actually ocean ridges and how they worked. To the example on the left, this is EM34 data. It's a quite large scale electromagnetic information, looking for a a sunk aircraft that crashed after takeoff for the 1950s. It's actually in a sort of 60 meters of water, but you can tell where it is. It's pretty conductive compared to the background sediment around Lake Washington in that example. Here's an example worked on a few years ago now. This is part of the London Underground network extension called Crossrail. They were looking at trying to extend the underground, basically increase capacity. And this section, they're crossing the Thames. You can see that on the top left image. There's the Thames crossing locations, those red dashed lines. So we did quite a few surveys with different techniques to try and look for where there's a good spot to cross it. But as part of that, we did a magnetic gradiometry survey. There's a sort of example of the equipment there on that bottom image. On the right image, we've plotted the resulting magnetic data on the topography of the river. That's why you can see a sort of the U shape, and you can see hopefully some areas highlighted by clusters of highly magnetic material. And these are likely to be unexploded ordnance from the Second War when the German Air Force was bombing London. So again, that's really useful for the people going to be working on this site. Obviously, try to avoid those areas or make them safe if they need to go into those. Environmental forensics, I mentioned earlier. That's important. You can use aquatic forensic detection techniques. This is an area in North Wales. You can read that there. There's some toxic waste leaking from drums that the Environment Agency were wanting help to find. The death study showed it quite a complicated history, mining for coal and clay and industrial waste dumped there. And in fact, in the 70s, there's a lot of sulfuric acid mixed with hydrocarbons, old clay bentonite, and these old metal 55-gallon drums in there. And that actually ignited, evacuating the nearby village, leaving some nasty tar waste and some of these remnant drums behind. You can see that picture from the 1980s at the bottom of that slide. So here we actually weren't allowed in the water because the water had a pH of 2, which is pretty low. You don't want to be putting your feet in there. So we actually sort of jury rigged up some old surfboards. You can see the picture and the plot here on the right, putting some magnetic radiometry instruments on it, and then hoiked it up and down this pond using some cable system and a GPS system on the top, trying to locate where the data is being collected from. And here's some results. So you can see on the left-hand plot, there's a sort of the whole pond is there. Obviously, blue is not very exciting, but you obviously see some clusters of highly magnetic material, which they then could identify and extract carefully with that, bearing in mind that water pH system. So that was magnetics. Sonar is quite a widely used tool. It's sort of a sonic system, so using sort of acoustic sound waves. It emanates out of some instrument, usually some sort of towfish, or some sort of instrument that's towed behind a vehicle, as you can see by both the schematic on the right and the images from John Schultz's paper on the left. Gets towed usually a few meters above the water sediment interface and produces images behind that, which I'll show you for you next. So this example, it's not a picture, it's a sort of an image of a reflective wave strength, so depending upon whether the sound wave gets absorbed or not. So usually clay will absorb more sound, so it'll probably dark, whereas sandier substrates will be whiter. So you can see here on the left, for example, the sort of long linear line, that's where the actual towfish has gone, but you can hopefully see that sort of sunken boat on the left. This is again from John's paper. I think he'll be talking about a different study on his talk later on in the day. And on the right, there's a drowned victim. You can see that, and it's sort of zoomed out. You can see sort of the head and the body and the legs in that case. That's quite a routine use of instrument to try and look for items, as long as you've got a relatively larger target than the background. So if the example on the right was in a rocky area, that's going to be a bit more tricky to try and find where the body is compared to where the rocks are. You can get water LiDAR. We talked a bit about airborne and ground-based LiDAR in the last presentation. So here's an example showing you Tower Bridge in central London on the left-hand one. You can see sort of the bottom of the Thames in quite some detail. On the right, showing a canal survey, looking for items of interest as well. So you can get quite a detailed look at what you think the ground's doing and the substrate's doing in that case. Talked about GPR in the terrestrial talk, but you can get water penetrating radar, which is basically radar in a boat. This is again from Alice's papers. You can see that the dinghy with this electric motor at the back to keep it relatively quiet for the the radar system in the actual dinghy itself, and that gets on its own system here, collecting data. So again, collecting 2D profile data, and in this example, there was a rifle parts were thrown into this lake. You can see the image on the right, and they actually did some tests on how far someone could throw something into the lake to get an idea of sort of survey area and also access points to try and limit the area that needed to be surveyed. And then it's an example of Alistair's work. So you can see on the data on the bottom left, so water obviously is at the top, and then you've got that strong signal from the bottom of the pond, and the actual rifle parts were actually detected, highlighted by that red circle there. And this is a classic case study that Alistair published a little while ago now, which was a jet ski accident. So someone was jet skiing in this lake and unfortunately had their leg amputated, but the victim wanted their leg back, so they were basically trying to recover this leg. So again, there's a sort of death study undertaken. You can see that on the data on the right, even to where the route that the associated speedboat took. Alistair's then collected a series of two-dimensional lines. You can see that on the bottom right of that figure, to collect data to try and work out where that might be. So here's the example on the left is some water penetrating radar data. So obviously you've got the lake at the top, you've got the dipping lake sediment, lake base dipping down from top right to bottom left, and there's highlighted for you there's actually where the sunken jet ski was located, and the leg was located under the jet ski. So again, a useful method to recover the leg in that case. I did mention wildlife forensics. Again, that unfortunately is a growing issue. So in this case, there was a witness stated there was a badger was weighted down, it was in a bag and weighted with some rocks and thrown into a ditch. So then Alistair was asked to go and try and locate that or retrieve it. So you see the picture on the top left with a dinghy in the relatively small ditch there, collecting data to try and work out where it might be. Now, if you remember from the terrestrial talk, we talked about different frequencies of data. That's why there's 100 and 200 megahertz frequency data or repeat data shown here. And you can see they're both reasonable data to collect, and you see that there's nice obvious half moon shapes there showing where the targets might be of both the rocks and the badgers, or picture shown on the right. Alistair's also been doing some control work, trying to see whether water radar or sonar would be more effective, or which sort of scenarios or variables it would be optimal. So they actually looked at revisited a site where some sort of 5 kilo contraband bags were sort of hidden within this canal. So you can see the picture of the canal on the bottom left here. So then looked at trying to collect data in this area to see what would be most effective. So there's a radar profile on the right. You can see the canal surface is highlighted for you, the bottom of the canal bed, and then there's some actual floating targets, which are fairly obvious. Some surface targets you can just about see there on this water surface interface, and there's a couple of buried targets as well, which you're not going to be able to see on the sonar, which I'll show you next. So here's a sonar image of it. So sonar's really good for looking at the bottom of the substrate. So again, you can see there's a little list here. So surface targets, you'd probably pick it up with sonars. The ones which are just on the bottom sediment in water interface, the sort of purple ones you'd also see, but you wouldn't see the ones that are buried with sonar itself. So again, you see they're sort of listed for you there. And then he came up with a sort of combined list. So here's a sort of aerial photograph. There's the old boat's position. You can just about see that on the bottom left there. And then some of the target positions as well to work out which ones you would look for, or which ones you'd use first. So, and in this example, they suggest using both methods, which obviously takes longer, but that'll give you more information on where targets are. But you still got to obviously get the dive teams to go and recover those items. So in summary then, aquatic forensic searches can be quite complex. It's not as simple as you might think, and there's some different techniques you could use to try and find them forensically, or at least using geophysics. And we covered the main ones. So we talked a bit about sonar. Can't penetrate sort of sediments, but you can cover quite large areas. You can use it in different environments, from marine to fresh water. We talked a bit about magnetics. That's pretty good for detecting obviously metallic targets, and different sort of configurations and equipment can cover or resolve small to large objects which can be buried as well. And then finally, we talked a bit about water penetrating radar. So that's pretty good resolution. You can see relatively small things. Tends to work better in fresh than salt water, and depends upon your area, and can even work in ditches, as we showed with that forensic example. So thanks for listening.